Welcome to 6.2 Special Right Triangles. We're going to start with a discovery lesson, so make sure you print out the discovery page that's located below the video, and then we're going to fill it out. So first off, discovery number 1 on the front. If we use Pythagorean theorem, we can find our variable here, x. So we're going to do 6 squared plus 6 squared equals x squared. And 6 squared is 36, so we get 36 twice, which becomes 72. We're going to take the square root, and we're going to simplify this. I know that 72 is really just 36 times 2, and the square root of 36 is just 6. So it becomes 6 squared of 2. And we're going to fill that out in the box here. So leg 1, which is one of our legs, right, is 6. The other leg is 6. And the hypotenuse is 6 squared of 2. So what I want you to do now is pause the video and go ahead and fill the front. When we come back, we'll do the back side. Okay, for the back discovery, I'm going to do example 1 again. Here the short leg is 1, the hypotenuse is 2, and the long leg is x. So we're going to do 1 squared plus x squared equals 2 squared. 1 squared is 1, 2 squared is 4. Subtract 1, we get 3. We take the square root, the long leg is the square root of 3. The short leg is 1, and the hypotenuse is 2. So go ahead and pause again, and go ahead and finish the back page. Now that we're back, we're going to discuss the actual answers to the discovery and what you should have figured out. First, on the 45, 45, 90, the relationship between the legs is that they're the same, they're congruent. We would call this an isosceles right triangle, or 45, 45, 90 is how we're going to always say it. The relationship between the legs and the hypotenuse, well, the hypotenuse is really just the leg times the square root of 2. So if the leg was 10, then the other leg would also be 10, and the hypotenuse would be 10 square root of 2. If we knew the hypotenuse, to go backwards, we would divide by the square root of 2. Okay, so on the back discovery, what you should have picked up is that the type of triangle is a scalene right, but better yet, we would call it 30, 60, 90. We always name it by the angles for these because they're special. The relationship between the short leg and the hypotenuse is twice the short leg. The relationship between the short leg and the long leg is the short leg times the square root of 3. So if the short leg was 10, then the long leg would be 10 square root of 3. And the hypotenuse would be twice the short leg, which is 20. If we knew the hypotenuse, to find the other legs, we would divide by 2 to find the short leg, and then we multiply by square root of 3 to find the long leg. From this discovery, we're going to take some notes. We're going to first find the formulas. So this is actually everything we just discussed. On the 45, 45, 90, the legs are the same. That's why we call them x. The hypotenuse is the leg times the square root of 2. That's why it's x squared of 2. On the 30, 60, 90, the short leg is x, and the hypotenuse is twice that, and the long leg is x times the square root of 3. The short leg times the square root of 3. Okay, so let's see some examples of this. So what I'm going to do is I'm going to use the formulas to set this up. Well, I know y is a leg on the 45, 45, 90. The leg is just x, so y equals x. I know that the hypotenuse is x squared of 2, so z equals x squared of 2. And I know the other leg is 4. Well, the legs are x, so x is 4. So now I can fill that in for the rest of the information. Y equals x, which is 4, so y equals 4. Z equals x squared of 2, well, x is 4, so it's 4 squared of 2. And those are my answers. On the small triangle, I know that y is my short leg, and that's x. I know that z is my hypotenuse, which is 2x. And I know that the long leg, 4 squared root of 3, is x squared root of 3 is the formula for that side. Looking at this, I know I can solve for x in that last equation. And I'm just going to divide by the square root of 3 on both sides, and I find that x is 4. Well, now that I know what x is, y is also 4, and z is 2 times 4, which is 8. You should now be able to finish the front side of the practice, which is the basic questions. And then we're going to talk about the notes from the back. So on the back, we have rationalized the denominator. There's multiple steps with this. The idea is we cannot have a radical in the bottom, in the denominator. So we're going to first multiply by the radical in the denominator over itself. So we're going to multiply by the square root of 5 over square root of 5. Then we're going to just multiply straight across. 3 square root of 5 is on top. And square root of 5 times square root of 5, that's the square root of 25. Now I'm going to take the square root of the perfect square in the denominator. Square root of 25 is 5. And now I'm going to simplify the fraction if possible. This one's already simplified, so we're done on this question. So let's see another example here. We're going to first multiply by the square root of 2 over square root of 2. Then we're going to multiply straight across. 4 square root of 2 over square root of 4. That becomes 4 square root of 2 over 2. Square root of 4 is 2. And then 4 divided by 2, that simplifies down to 2. So it becomes 2 square root of 2. So we multiplied. Then we multiplied straight across. Then we took the square root of the bottom, and we simplified the fraction. So there we go. The reason we use this is because on this type of question here, well, in this one, 8 is the hypotenuse. Well, with the 45, 45, 90, the hypotenuse is x squared root of 2. We don't have a square root of 2 in here. So we're going to have to rationalize the denominator. Well, the legs, z and y, are both x. So z equals x and y equals x. But the hypotenuse, 8, equals x squared root of 2. So to solve for x in this question, we're going to divide by the square root of 2 on both sides. And we get that x equals 8 squared over square root of 2. And this is where the rationalizing the denominator comes in. We multiply by square root of 2 over square root of 2. Multiply straight across, 8 square root of 2 over square root of 4. Square root of 4 is 2. Simplify the fraction, 8 divided by 2 is 4. So we get 4 square root of 2. That's what x is. So we fill that in for z and for y because they're the same. Okay, our final example here is a 30, 60, 90. Well, the long leg is 5 in this question. I know the short leg is n, it's x. The hypotenuse, m, is 2x. And the long leg, which is 5, equals x squared root of 3. To get x by itself, we divide by the square root of 3. Then we rationalize the denominator. Multiply by square root of 3 over square root of 3. Multiply straight across. 5 square root of 3 over square root of 9. Square root of 9 is 3. So it becomes 5 square root of 3 over 3. So that is x, so therefore that's what n is. Well, m is twice that, so we just double the numerator. 5 times 2 is 10, so it becomes 10 square root of 3 over 3. Okay, that is it for special rights. Look forward to a more advanced lesson in class.